Uh, Hello. Good afternoon, all my dear students. Hello. Good afternoon, all my dear students. Dear students, please, am I audible? Hello. Please respond me. Am I audible? Hello. Hello, dear students. Am I audible?
Yes, sir.
Okay, thank you. And my screen is visible to everyone. Okay, I think so. Yeah.
Yes, sir.
Okay, thank you. Thank you. Uh, Dear all students, again, welcome to my lecture. So already we have started with the fifth unit as per your syllabus. So as I caught commands, that is bit I am going speed. So now only I have to clear you all of you. So now onwards we will go slowly because in the fifth unit only that programmable dynamic memory access controller 8257 is the remaining topic. So here in this fifth unit topic, already we have studied maskable and non-maskable interrupts, interrupt service routine, and one of the microprocessor architecture, that is 8259 architecture, block diagram, mode of operations, working functionality we have studied. Okay, very big things, very few things I have to taught in this unit. So don't take this is as to panic. Feel free and ask if anything you are not understood. My notes, whatever I prepared, that is so much easy way for understanding to the students what I think so. And whatever I covered, same whatever I prepared the notes, that one only I covered in the lecture. And almost this microprocessor you studied in your diploma course also. So in that thinking of the way I am going to cover is of the syllabus. But anyhow, don't feel bad. I am now onwards going slowly. Okay. So dear students, in the unit number 5th, that is interrupt chapter, under this we studied introduction of interrupt. In that interrupt introduction, we studied definition of interrupt. What is definition of interrupt? The interrupt which is going to be handled some abnormality conditions during the program execution. It is occurring during the program execution. That time, those kind of debugs we are going to handle by using interrupt. That is our main concept of interrupt, main concept of unit number 5. So under this, we have studied two main category of interrupts. What are those two main category of interrupts? First one is hardware interrupt, and the second one is software interrupts. Here in the notes only at the beginning, I have to given you hardware interrupt and software interrupts. But as per your syllabus, you have hardware interrupt category. So again, under the hardware interrupt, there are two subtypes of interrupt, that is maskable interrupt and non-maskable interrupt. Maskable interrupt and non-maskable interrupt. There are again two categories comes under hardware interrupt, and under the software interrupt, 256 software interrupt categories are there under this, but those are not for your syllabus. Just for we will go through hardware interrupts. So in that hardware interrupts, I have to clearly explain that is non-maskable interrupts, which is can be make it as not disable, make it as not disable continuously. It is going to be execution of the program. That time this one is going to be handled. So after that, interrupt or we say maskable interrupt. Both are same. Normally you call it as maskable interrupt or simply you call it as interrupt. So this is the interrupts that enable using set of interrupt with the flag instructions. Okay. So this one we studied. After that we studied service uh, that interrupt service routine. After that we studied interrupt service routine. So this interrupt service routine, whenever the bugs are happened during the server side, so many times if you are browsing or if you are downloading anything from the browser, many times you have to get not downloaded or the server is busy or it is going to be a cursor is roaming around it and goes into the buffer safe state. So those kind of problems, abnormality things is going to be handled by using the interrupt service routine or we say normal interrupts. Okay, these things that clear explanations I have to given you. So maskable interrupts and interrupts, all these covered. So next we will come to the topic of 8259 microprocessor chip. That one we called it as programmable interrupt controller. That one we call it as programmable interrupt controller, that is 8259. So in this just we are going to study block diagram or we say architecture and special features of 8259 and working functionality. That one already we have explained that architecture of 8259 and this all the blocks whatever comes under this, all the blocks we have studied, that is based on interrupt request, priority resolver, in service register, read and write cascade buffers, all these blocks we have studied. And this all the pins also we studied in the last lecture, right? So again, that pin configurations also we studied, for a particular pin is used for what purpose. Okay, so that sequence of 8086 and command words also we studied. There are two types of command words, that is initialization command words ICW and OCW, Oper operation command words. Okay, so again in these three categories are there, that all things we studied. This is just for to solve the difficulties or abnormal condition during the execution of microprocessor program. If suppose those problems still it is high, still it is difficult, which is not going to solve by 8259, for that time the one more microprocessor chip is get existed, implemented by the inventors, that is we are going to saw now, is nothing but programmable dynamic memory access. So 8259, that PIC programmable interface controller, which is used for static purpose, but this 8257 is used for dynamic purpose, that is programmable. That's what we call it as dynamic memory access. Programmable dynamic memory access controller of 8257. This is the dynamic one. And 8259, whatever previous architecture you studied, that is static one. Okay, that's the differences. So by using 8257 dynamically, we are going to handle the bugs of microprocessor programs. Okay. So here, first we will look into that some features. So what is 8257? We will look into here. So some operations performed on this 8257 with a dynamic memory access. So here it is initially when a device has to send the data between the device and the memory. It is when the device and the memory, the 8259 within static means what? It is within the blocks of 8259 we are going to transfer the data. That time we are going to execute the program. That time any problems are occurred, which is going to be handled by 8259. But here in the 8257, when the device has to send the data between the device and the memory, one device to another memory, the device has to send a dynamic memory access request, or we have to say DRQ, dynamic memory access, with a request to the DMA controller. Okay, so very important point. For that specifically, we have to use this 8257. And the next main operation point is the dynamic memory access controller sends the hold request. Hold request means what? It is sends the request for the response purpose to the CPU and waits for CPU to assess the hold acknowledgement. Hold acknowledgement means what? Whatever we are sending the request, that request is going to be process it and hold it for responding. Hold acknowledgement. So the next point, then the microprocessor in a tri-states all the data. Tri-states means what? Address bus, controller bus, and data bus. Tri-state means data bus, address bus, and control bus. The CPU leaves the control over the bus and acknowledges the hold request through the hold acknowledgement signal. Whatever in the second point that hold acknowledgement is happened, that is going to be transferred to the signal with hold request. Okay. And in the fourth operation of main thing, whenever the CPU is in the hold state and the DMA controller has to manage the operations over buses between the CPU and memory and IO devices. So while the data is transferred between CPU, between memory, between IO devices, that time the 8257 is going to do the interesting. Okay. So for these main three operations, we are going to use dynamic memory access microprocessor of 8257. Okay. Now we will see the what are the main features of 8257. What are the main features of 8257? So in the 8257, it has 4 channels which can be used over 4 input and output devices. 4 extra channels we are using, and each channel has a 16-bit addresses. So it is there the architecture. Channel number 1, 0 means channel number 1, channel number 2, channel number 3. 0 to 3 means totally 4 channels we are using, and each are 16-bit address lines. Okay, that is the first 2 point. It has a 4 channels, and each channel has 16-bit address and 14-bit counter. There are 4 channels, and each channels are 16-bit address line and 4-bit counter, and each channel can transfer data up to 64 kilobytes. Three main features. Each one of channels that can transfer the data up to 64 kilobytes, and each channel can be programmed independently because there is no dependent on one and another. So all programmed in independently, and each channel can perform to read, transmitter, transfer, and write, transfer, and verify the transfer operation. So each channel can perform to read the transfer, write transfer, and verify transfer operation. And the next main features of 8257, it generates mark signal to the peripheral devices that 128 bytes have been transferred. Mark signal means what? So there is a one signal is generated which is having 128 bytes of transferred signal. So that one is main features of 8257, and it requires a single phase clock. So previously you have to use no clock generator for the 8086, but in 8087 you are using a one clock 8284 chips you are using. Here also in the 8257 we are using one single phase clock, and the frequency range from 250 hertz to 3 megahertz is usable in the 8257. What is the frequency range? That is 250 hertz to 3 megahertz, and it operates in two modes called it as master mode and slave mode. So I think all of you aware with master mode and slave mode. So again I have to explain you, please be remember what is master and what is slave. So here master is always one and slaves are n numbers, many numbers. For example, for the today's lecture, I have to prepare a Zoom link and I send it to you, all of you. So it means that I am become a host and all of you all become a client. Am I right? So in a whole meeting, only one host is there and remaining all are means clients, means just a listeners. So who is the one host? Nothing but me. I become a master here. My PC is become a master and all you all become a slave. So it means that master is one, slaves are many, host and client like that. Okay. So that one, your 8257 is works on master and slave mode. So this is the architecture of the 8257. So here for that, I have to prepare one small notes here for the printed purpose. That one also you'll just come to the point. Again, same points only I have to repeat it here. Two modes, that is master and slave. 128 bytes have been transferred and each channel, okay, everything is going to be fine here. So in that architecture of 8257, so as I explained in the features of 8257, so I make it less slice. I think it is clear visible to you. Okay, I think is it? Yeah. So just you have to make a screen big and you will visible to that diagram. So dear students, this one we have to say 8257 architecture. As I explained in the features of 8257, it is having four channels: channel number 0, channel number 1, channel number 2, and channel number 3. Okay, and each channels are identical, means same channels we have to use, and each channel is using 16-bit address lines. Each channel is used for 16-bit address line, and each channel is having one data request and data acknowledgement. D request and D acknowledgement means what? DMA request and DMA acknowledgement. Request means what? Whatever it is asked to get something is nothing but request. And acknowledge means what? It is responding what the data is particularly needful to solve the problems. That is acknowledgement. Like this, all these four channels we are connected in a cascade. Internally, these four channels we have to connected with priority resolver. Very important here. All the channels are get connected to priority resolver, and all four channels are connected to internal bus. Through the internal bus only, all the bugs and data or the information is going to be carried between this internal bus, and remaining these are related to the pin configuration, that is data bus buffers, uh, read and write logic, and control and mode set of logic. Extra three more blocks is used for data bus buffer, read and write logic, control logic. Okay, so the data bus buffer is having D0 to D7, means 8 data lines are present here. And in the ready or write logic, we have to use input and output read, input and output write, IOW and IOR, means input and output read, input and output write. And there is a one single clock we are used. As I said in the features of 8257, we used one single clock and one reset pins used here. So again, A0 to A3, it means A0, A1, A2, and A3 are used for address lines in the read and write. And this is for two signals. CS bar is used here. After that, A3, A4, A5, A6, A7 are used with control line mode set logic, because this is a lower bit with read and write and higher bit with control logic. So in this ready state, request, hold acknowledgement, hold request, and MEMO, that is memory read and write, that memory write, okay, acknowledgement, and enable bus, that is ADSTB also we have to use it here. With then TC means transfer control, and there is a mark, that is 16-bit mark signals also we are using. So all these pins one by one we have to study, used for particular for what. But first before that, you have to come to know the architecture functionality. So come to the functionality here, the internal bus which can carry the bugs or whatever the problem is occurred during the execution of program, and that bus is transferred to it to all control logic read and write data bus controller. So in the data bus controller, it is access all the things, and it is take the logic of read and write, how is going to be resolved it. Then it is take the control logic for the solution, send it back to the internal bus. So through the internal bus, again all the channels are going to be accessed, and it is used dynamic acknowledgement and dynamic request. Send the request, get the acknowledgement, send the request, get the acknowledgement of each and every channels. Based on the priority wise, it is going to be resolved by using the read and write control logics. Okay, so this is the main architecture of 8257. Just here three blocks you have to draw, and here four blocks you have to draw, here three blocks, and one more is priority resolver. Only 8 blocks you have to remember in the 8257 architecture. And at the mid, we have to indicate, that is internal bus. Through the internal bus only, we have to transfer the data, and we have to receive the verified data again back to execution of the program. So this is the very important case of 8257. Okay, I think you will get it. Just for similar channels and similar data functions are there. So now I will go to each one of pins. Okay, so here in the register operation of 8257, it has four main independent channels. Those you have to saw. For that, each channels of 8257 has a pair of 16-bit registers. So that DMA address register and terminal count register. See, this is the TC means what? It is a terminal count register. Okay. So again, there are two common registers for all the channels. That is mode set registers and set status register. So in that, there are total of 10 registers in the CPU. Okay. So for here, just one tables I have to mention. It's not needful. Just for your information, I have to mention here. So next one is DMA address register. In this, so each DMA channel has a DMA address register, and that function is to store the address of starting memory location, and which will be accessed by the dynamic memory access channels. So the starting address of the memory block, which will be accessed by the device, is first logged into the dynamic memory address register to the channels. So the device that wants to transfer the data over a DMA channel and that access the block of memory with the starting address stored in the dynamic memory access address. This is for the DMA. And here in the terminal count, so come to this DMA is there, that is terminal count. Okay, this is the terminal count is here. So in the terminal count register, each of the 4 DMA channels, all channels are nothing but a DMA channels only, of 8257 bus, one terminal count register is there. So in that, the 16-bit register is used for ascertaining that the data transfer through a dynamic memory access channels, and it causes or stops up to the required number of dynamic memory cycles. So the this register should be written before the actual DMA operation starts. Okay, because before only the dynamic should be happen going to start of operation. For that, the lower order 14 bits of the terminal count register are initialized with the binary equivalent of number of required DMA cycles, and it after the cycles that terminal count register contain will be determined by the uh, by and that finally becomes zero after the required number of DMA cycles. Okay, so the 14th and 15th pin, that register indicates the type of DMA operations, whether it may be a mode of operations that is explained. So here in this device wants to write the data into the memory. The dynamic memory operation is called as write operations. If it is going to be read it, then it is called as read operations. If in the 15-bit register, this will be set to 1 and the bit 15 will be set to 0. Okay, that table is I have to give here with 15 and 14 bits. If it is 00, then verify the DMA cycle is occurs. If it is 01 condition, then it read the DMA cycles. If it is 10 condition, then it read the DMA cycle. And if both are 1, then it should be, we have to say that illegal. But because by this table, we understand that any one is high or all are 0. Okay. Except this last condition, because of it is illegal, any one is 0 or anyone is high. Okay. So this one is the uh, terminal count register. After that, the mode set register in the 8257, the mode set register is used for programming, and the 8257 has for deployment of system. So the function in the mode of operation register, the function enables DMA channels individually because all DMA channels are independent. Whatever 4 channels are present in the 8257, all are independent. So all channels are enabled individually, and also to set the various modes of operations independent. To set the various modes of operations independently. A DMA channel should not be enabled till the DMA address register and terminal count register contain a valid information. This point is very important. So it should not be enabled until and unless the valid information is getting. Otherwise, an unwanted DMA request may be initiate a DMA cycle probably, so that destroying the valid memory data. So the A10 to A15 pins of DMA starting addresses, that is C0 to C14, and the terminal count values are used here with the verify bit of or read and write operations. Okay. So at the lastly, the mode set of register format. The operation mode set of register format, which is D0 to D7. So that is D0, D1, D2, D3, D4, D5, D6, D7. Totally 8 bits. The first bit is used for terminal count status channel of 0, terminal status channel 1, 2, 3. And here we are using, that is the enable rotating priorities, enable extended write, and enable that terminal count starts. So enable auto read, these 4 pins. As per singular particular pins, we have to say it as D0 to D7. Okay. So next one, that is to stop the bit of the selected channel in the disabled after the terminal count condition is reached, and it further prevents any DMA cycle on the channel. And if the terminal count stop bit is programmed to be 0, so the channel is not disabled even after the count is reaches to 0. That is the main problem, which is going to be solved by using this 8257 microprocessor. Okay. So the auto load bit is set to channelize with the enabled for repeat block channeling operations, and the channel restores are registers used to store the block of reinitialization parameters. So that is dynamic memory access, starting address, and the terminal count. So after the first block, means first channel registered, the DMA and the channel 2 registers are loaded into the corresponding channel 3 registers. For next block transfer, it can be updated with the flag set. That can be updated with the flag set. So the extended write bit set to 1, and extended duration of the memory write and input output read write signals by activating them into the peripheral devices for resolving the problems. That is by 8257. Okay. So at the last, there is a one status register we are using. SR means status register. It is a 4 bits contain, and the terminal count status for the 4 individual channels. And also, it any of these bits is set to indicate that the specific channel has to reach the number of terminal count conditions. Okay. So this is the thing of at the end of this operation. So that flag cleared with the reset of 8257, or by resetting the auto load bit to the mode of set register. So the update flag set to the contents of channels with the 3 register to the corresponding register of channel 2. Whenever the channel 2 reaches the terminal count condition, and the block of the next block is to be transferred using auto load features. So that terminal count with the channel 0 to 3, I have to mention here for D0 to D3 means total 4 channels, and remaining at the point of D4, that is going to be updated with the flag register. So this is all about uh, the mode of operations of 8259. So here just three things I have to explain. One is what features of 8257. Another one is architecture of 8257. I will say it is a block diagram and this working functionality. Okay. Only three things we have to study it till now. So after that, we will go to this each and every pins Whatever particular pins are used in 8257, that one we will going to see now. So just for uh okay, just for 2 minutes. So just to go through this one, 8257, what are the things I covered today? Programmable DMA controller 8257 from the page number 28 to 35. Very simple thing. Features of 8257, architecture of 8257, and functionality of 8257. After that, we will go for particular pin of 8257 is used for what. Okay. So just take a 2 minutes, just have a cup of water and we will start. Just for 2 minutes. Okay, fine. So here, this is says about all about your 8257. So after that, we'll move to some pin configuration means particular pin is used for what. So here I have to make test microprocessor 8257 DMA controller. So that features we studied, okay, and same because that points I have to explain. And this architecture also we studied 8257 architecture and pin configurations we have to study. So this is the pin diagram. So all pins are used. We have to study now. So dear students, yes, okay. So this is the pin configuration of 8257 DMA controller for at the pin number 1, IOR, IOW. IOR means what? Input and output read, input and output write. So memory, read and write. This MEMW means MEM means memory, read, memory write, and this is the mark signal. Ready state, hold acknowledgement, and that enable high hold request, two signals, clock, reset pins, dynamic acknowledgement 2, dynamic acknowledgement 3, the dynamic request 3210, and this 20 pin is used for ground, and here the 40 pins is used for A7, A4 to A7, and 36 is used for terminal count, and A0 to A3 used for 35 to 32. So VCC is used at the pin number 31. So data lines from D0 to D4 up to D7 used for 30 to 21, and between 25 and 25 pin number used for data acknowledgement 0 and data acknowledgement 1. Okay. So this one we will study in now. So here DRQ not to DRQ. This one pin number 16 to pin number 19. Pin number 16 to pin number 19. So that is DRQ not to DRQ. So these are the four main individual channels of DMA request inputs, and which is are used by the peripheral devices for using a DMA services. Whenever the fixed priority mode is selected, the DRQ node has the highest priority and DRQ3 is the lowest priority among them. So DRQ3 is the lowest priority and DRQ node is the highest priority. Next one is data acknowledgement, DACK. Okay, so that acknowledgement is here. In that DACK node to DACK3, these are the active low DMA acknowledged lines which updates the requesting peripheral about the status of the request by the CPU. So these lines can also act as strobe lines for the requesting devices. And the D0 to D7, these bidirectional data lines which are, so next is we are going to use D0 to D7. So here from D0 is at the pin number 30 and to the pin number 21. In that, these bidirectional data lines which are used to interface the system bus with the internal data bus of the DMA controller. So the slave mode means what? All are services. Slave mode, which can carry the command words to 8257, and the status word of the 8257 is the master. Okay, whatever the master is there, that is going to be connected with all the slaves, and data should be get access. So, and to overcome the problems of evening interrupts. So these lines are used to send the highest byte of the generated address to the latch. So this address is further latched using ADSTB signals. Okay. So next one is IO all. It means that input and output read, which is for the bidirectional tri-state input line. Why it is tri-state? Because it is using data bus, control bus, and address bus, which is used for the CPU to read internal registers of the 8257. And in the slave mode, the master mode is used to read the data from the peripheral devices during the memory write cycles. So next one, that is input and output write. So it is an active low bidirectional tri-state line which is used to load the contents of the data bus to the 8-bit mode register. The upper and the lower byte of 16-bit dynamic memory access addresses register are the terminal count registers. These are used in input and output, right? In this master mode, it is used to load the data of peripheral devices during the DMA memory read cycles. Okay. Next, use the clock. As I said earlier, one single clock is used in the 8257. It is a clock frequency signal which is required for the internal operations of 8257. And that one more signal used for reset purpose. That reset signal is used for DMA controller by disabling at the dynamic memory access channels, because we have to use totally 4 channels in that with the 16-bit of each. And the next one is A0 to A3. Four address lines we are using. So that four largest significant address lines and the slave mode, they act as in the input which selects one in the register to the read or return in the master mode. So they are the four least significant memory address input lines generated by 8257. Okay. So next one, that is the CS, means selective lines or chip select lines. We say it is an active load chip select lines. In this, the slave mode, it enables the read and write operations to the to and from the 8257. So in the master mode, it disables the read and write operations to the or from the 8257. So here that A4 to A7 signals, as in the pin diagram, A4 to A7. So this one A4 to A7 from pin number 37 to 40. that is A4 to A7. These are the higher nibble of the lower byte address generated by the dynamic memory access in the master mode. And for the ready state, it is always an active high synchronous input signals is used, which makes the dynamic memory access ready by the inserting wait status. Okay. So the hold acknowledgement and HR, that hold request, for that hold request, the signal is used to receive the hold request signals from the output devices in that slave mode. So it is connected with the dynamic request input to the 8257 microprocessor. And in the master mode, it is connected with the hold and hold acknowledgement of the CPU, central processing unit. So at the last, again, that is hold acknowledgement. Whenever it is again sent back to the responses, is nothing but an acknowledgement. It is the hold acknowledgement, that signal which indicates the dynamic memory access control that the status bus has been granted to the requesting peripheral by the CPU when it is go set to 1. So next one, MEMR means what? Memory read signals. MEM is what? Memory read signals, which is used to read the data from the addressed memory locations during the DMA read cycles. So next one is MEMW, which is used to active low 3 signals, that is used to write the data to the address memory location during dynamic memory access write operations. So next one is ADST signals. This signal is used to convert higher byte of the memory address generated by the dynamic memory controller to the latches. High to low for machine understandable conversion is happened with the ADST. So next one is AEN signal pin. This signal is used to disable the address or bus data, address bus or the data bus. That AEN is used for to disable the address bus or a data bus whenever the data is not available during the transfer purpose. So next one, that is TC, or we say terminal counter. In this terminal counter, which indicates the present dynamic memory access cycle to the present peripheral devices. That is terminal counter. So next one is the mark pins we use. This is very important, that mark pin is activated after each 128 cycles of integral multiples of the beginnings. So it indicates that the current DMA cycle is the 128 cycles of integral multiples of the beginnings. So next one is that power supply is connected to this pin. It is a power signal which is required for the operations of the circuit. So all the pins, whatever containing this 8257, I have to explain to you. Okay. So dear all students, for this today 1 hour, just I taught about 8257 DMA controller, 8257 microprocessor DMA controller. Just brief idea. So all of you come to this WhatsApp group. In that group, I will send to you. Okay, there is our microprocessor DSY group. So in this group, I have to send this short notes of pin configuration explanation. So here desktop. Yeah. Okay, dear students, all of you come to this document. Okay, just I have to save it here. That's fine. Okay, yes. 8257. Yeah, all of you come to this microprocessor DSY group. In that group, I have to share with you one more printed short notes what I used for explanation. Please you check it out. Okay, Vinayak, Mani, Pawar, Parth, Saurabh, all of you just check it out. This notes, whatever I send it you today, now itself. So very easiest and all the concept of pins, I have to explain it clearly in that. Okay, so just you have to check it out and you find. So just today's, I think all of you understand and today's my class is on an average, what I understood. Okay, so I also you have to tell me if is it speed or on the average or still I have to go to slow. Whatever your comments is there, please you have to text me a message. According to that, I have to cover the syllabus. But only our main intention is to understand the subject to you all of you. Okay, dear students, this much things, whatever I covered today. So, dear all students, what you will do now? It is 110 up to 120. You go through these notes about this 8257 and you scan this very well. Understand the concept. Okay, for this 10 minutes, you take a study for this 8257 up to exactly at 120. Exactly at 120, I have to start lab programs. One of the lab programs we have to cover. That is the fifth program as per your syllabus. We have to cover it today. Okay. So for this 10 minutes, please go through this study material about 8257 and you study well. Just for 10 minutes. After 10 minutes, don't log out. I will start lab program of program number 5 as per your syllabus. Okay. Yes, fine.
Hello, excuse me, sir.
Yeah. Hello.
Sir, you are not audible.
Now am I audible?
Yeah, sir.
Yeah. Okay. I muted this one. Yeah, fine. So dear all students, what you will do? See, actually my machine is not working with the TOSM. There is some Windows problem is here. So whatever I given to you in this program, this code, so can you practice in your machine? You have to go and type and execute this program. Up to that, I have to make correct with my machine. Okay. Please carry on this program by typing in your machine. And once you got the output, please send me your output screen to me. Up to that, I have to make correct to my machine. Okay. Yeah. So. From 1.4 we don't know.